Hey everyone, and welcome to a new video. Federico here. In this video we're going to see how to get started with CodeBox inside jit.gen to work with matrices and create, for example, 3D positions for GGL multiple objects, create complex particle systems, and in general everything that requires matrix operations. I have a series of videos about CodeBox already, but this is more like a refresher to get you ready and dive into the other ones if you are interested. So without any further ado, let's start. So since jit.gen is an object that is used to make operations on a matrix, we need a matrix. So let's create a jit matrix. Let's give it 3 planes because we are going to work with 3D shapes. So we need 3 planes for the positions of x, y, and z. And for the scale, and let's create a matrix that is 10 by 10, right? So we will have, if we use this together with a GGL multiple, then we will have 100 shapes. So let's create our jit.gen here, and then let's create our GGL multiple. Draws to main, which is the name of my world, there's 3 inputs. Let's say GL params, and let's say we give it position. Oops, let me move these out of the way. We give it position, scale, and color. If we connect this here, nothing is gonna happen. Let's connect the metro, so the bang from the center of JIT world to the matrix, so it will, every frame it will update the calculations inside jit.gen. And then we need to actually create our shape. So this is going to be a grid shape, which just draws to main. We set automatic to 0, and maybe we set a shape as a cube. And since we got our skybox here, we can also create a GGL PBR, which will use the skybox for the reflections, connect it to both the multiple and the grid shape. I'm not sure if you need to connect it actually to both, but this will definitely work. So let's go inside jit.gen, and we are going to see how CodeBox works, right? So let's go here, let's transform this plus operator into a CodeBox box. Now in the code box we can write gen code, so the same stuff that we will write inside a gen patcher, but we're going to write it using actual code. I mean, this is also code. This is like textual code instead of these graphic operators that we have on Max. So in CodeBox we can use this text code. Now let's see what we got here. We got an output 1, which corresponds to the output from the CodeBox, and then we have 2 inputs, which correspond to the 2 inputs of the CodeBox. Now let's say that we want to have 3 outputs because we need to have the position, the scale, and the color. So let's go inside jit.gen and say output 1 is equal to, we could set it for example, equal to snorm. Snorm is the signed normalized coordinates. It's the same operator that we will have here in the patcher. And in the CodeBox is called exactly in the same way. Then the second output is the scale, which we can set equal to 0.1. And the third output is going to be the color. Now the color, it's going to be a vector with 3 components because our input matrix has 3 planes. So the maximum number of planes in the output of jit.gen will be 3. So we can have a vector with 3 components for the color. We will just set it to white. So to create a vector in CodeBox is the same what we will do here in the patcher. But here we need to use this parenthesis because this is like constructing the vector object using these 3 values separated by commas. So now our CodeBox object has actually 3 outputs. Every time we create a new output, it will appear also in the CodeBox box. So let's create actually the outputs in the patcher. So out2, out3. And let's now go in the patcher and connect these to the inputs of the GL multiple. And as you can see, what we get here is that we start to see our cubes. And they are placed in this square shape because we're using snorm for the position. So the x position will go between -1 and 1, the y position will go between -1 and 1, and the z axis will just be set to 0. Cool! Now let's see how we can create a variable inside CodeBox. Now a variable in programming is simply something that stores some data. In the case of GEN language in CodeBox, it could be a number or could be multiple numbers. So let's create a variable and call it output position, outpos. And let's make this a vector. So we will use for the x component of this for the first component of this vector, we will use snorm.x, and if you remember, when we are in the patcher, in the gen patcher, we can use switch to switch the single components of a vector, right? So, for example, if we would want the x component of the sign normalized coordinates, we will say switch x, and this will give us the x component, while inside the code box we can just say snorm.x, and this will give us the x component. Now let's say 0 for the second component and snorm.y for the third component, which is the zeta position. So this is the x position, this is the y position, this is the zeta position of our cubes. And if we use now that variable instead of snorm, you can see that our square of cubes is now flat because we are using the y coordinates, y signed coordinates for the zeta position. So this will be the x position, and this will be the zeta position. So nothing too difficult, right? Let's now see what else we can do in CodeBox. For example, you know that in the patcher we can say param, I don't know, something, and then we can access it from our max patcher. We can do the same thing in GEN. So we can say, for example, param ypos, and then open a parenthesis, give it a default value, and then close it. Now the only thing to be careful here is that this can only be on the first line of the code box. If we will put this after this other variable, it will give us an error. Declarations must come before any other line, I guess, something like that. So this must be, when we declare parameters, they must always be at the top of the code box. That's just how it is. So let's try to see if our parameter works. Let's go in the patcher, and let's say prepend xpos. It's connected to jit.gen, let's get a float number, and it's not working because we never used it. Right, I wanted actually to place it instead of this 0 here. So let's try now, and of course it works. Cool, so this is how we can declare parameters. So let's now see in CodeBox how we can use if and if-else statements. So for example, let's say if cell.x, and cell, if you remember, is this operator that gives us the coordinates of the input matrix in integer numbers, so between 0 and the dimensions of the matrix -1. So let's say if cell.x module 2 is equal to 0, so this means if the coordinate x of our matrix modulo 2, which means a modulo of a number, if you remember, even from standard max patching, is an operator that gives us always the numbers included between 0 and the number that we use for the modulo -1. So it always will cycle through these numbers. So in this case will just give us a 0 and 1, but this was a 3, it will give us 1, 2, 0, 1, 2, and then never arrives to 3. So inside here, if we say if cell x is equal to 0, then we could say that ypos is equal to 0.1 or 0.2, for example. And then actually, if we move this line below that, then we can see that something should happen. Oh, sorry, that's a good one. Can't assign to parameter y position. Of course, I cannot modify a parameter from within the gen patcher. So let's actually change the name of this parameter. Let's call it time because we're going to use it later. And let's create this ypos. Let's create it just as a simple variable. And now we can modify it as much as we want. So if cell x modulo 2 gives us a 0, and since it's a modulo 2, it will once give us a 0 and one gives us a 1. So if it gives us a 0, we set the y position to 0.2. And so we will have that one line of cubes will be raised up, and then the next line will not be raised up. Cool. What if we want to use also the cell y coordinates? So we could go inside our if statement and say if this is true, or if cell.y modulo 2 is equal to 0, let me go back to Italian keyboard, is equal to 0, then do that. And this will give us this kind of checkered pattern. So this double vertical line, which are called pipes, I think, this means or. So either this is true or this other statement is true. If one of the two statements is true, the code inside the if statement will be executed. So that's how it works. We could even modify the color. So for example, let's create a new variable and call it out color, and let's assign this to this vector with three ones, which will give us a white color. And let's say out3 here is equal to out color, right? And we can say if this is true, then out color is actually equal to a vector with all zeros. So, oh, but this will not work because we're using a ggl_pbr. So if we would remove that, then this would work. We would have that the top cubes are black and the bottom cubes are white, right? Yes, but that's all good. We understand how this works. So let's actually remove this from here. Cool. So let's now see another feature of the CodeBox, which is functions. So in CodeBox, we can use functions differently from what we can do in the patcher. Well, in the patcher, you could think that a function is represented basically by a GEN sub-patcher, or like a patcher inside the normal Max environment. In GEN CodeBox, we have functions. And a function is basically a reusable chunk of code that we can declare once and use it a bunch of times in every part of the code that we want. So let's create a function like this. Let's call it, for example, modify ypos or something. It works like this. We write the name of the function, we open a parenthesis and then close it, and then we open this graph parenthesis. And here is where the content of the function is going to go. So, for example, we can just get this code that we used here, paste it there, and it's giving us an error. And it's telling us that function's definition must precede everything else. So, okay, I did forget about that. So apparently we need also to put this before params. So exactly, the param must be below the function's declaration. The function declaration is the first thing that we must put on top of our code. Okay, so in order to make this function work, we actually need to create a variable ypos inside the code of the function, the block of the function, because this ypos here is not valid inside this function. So in a lot of programming languages like JavaScript, for example, this will actually work. If we declare like a global variable here, this would also be valid inside the function, but in GEN this is not the case. So we have to declare it again inside the code of the function. We could call it whatever. We could also just call it y, for example. And then in order to use it, we need to return it. So return means this is going to be what the function outputs. So for example, here, when we are declaring ypos, we can set it equal to modify ypos. And this should give us the value of the y. Now, unfortunately, this is not working because also the cell variable, which is a built-in variable in a GEN environment, will not work inside a function in GEN. So what we need to do is to pass this cell as an argument to the function. Now, an argument to the function is simply something that we can put inside the parentheses of the function, and this can be used by the function inside the function code block. Now, if we do that, it will also not work because it doesn't like that we are calling it cell like the global, like the built-in variable inside gen. So we need to choose another name, and it doesn't matter an argument. The only important name for the argument is when we use it in the when we actually use the function. But in the function definition, it doesn't matter which name we actually give to the argument. So it could be whatever. I'm just calling it chords, and now it will finally work. Cool. So the argument cell is the built-in variable in gen, which gives us the coordinates in integers. Inside the function, we can just choose whatever name to represent that variable. Okay, and then we return the value that we declared inside the function. We modified it, and then we return it to use it inside our code. Cool. Now let's see one of the main features of CodeBox, which is basically probably the most important reason to choose to use CodeBox instead of standard patch programming, which are for loops. So in the Max Patcher is almost impossible to make, or very difficult to make for loops, very complex, while inside CodeBox we can very easily create for loops. So a for loop allows us to repeat a bunch of code as many times as we want. Let's see how this works. So let's go here and say for, and it works like this. We define a variable, which usually is called I, and we assign it to 0. This is going to be our index, our counter. And we say, let's just create a variable here above and call it iterations, and let's set it to 5, for example. And let's say I is less than iterations, and then I plus equal to 1. So what does this mean? We start with I equal to 0. We say execute this code that is inside this graph parentheses as long as I is smaller than iterations, and then augment I of 1. So in a lot of programming languages, we could just write I++. This is not allowed in Gen. We actually need to write I plus equal to 1 if we want to add 1 to I. So our cubes, unfortunately, they disappeared. I don't know exactly why, because we didn't do anything bad. Doesn't like that there is an empty for loop, maybe. So let's fill it, and let's say that y pos, let's say plus equal to, for example, it's a bit tricky to demonstrate what we can do with for loops, because it's mostly used when sampling other cells of the matrix, but we can also use it in a different way, which is, for example, we could say this is the sign of S norm x, for example, which are the sign normalized coordinates again, multiplied by 2 pi, which is the built-in variable in gen, which gives us the value of pi by 2. And then we multiply it by, for example, by I, and let's see what we get. Okay, in order to better understand what's going on, let's actually assign y pos to 0, and we can comment out this modify pos cell in this way. So with these 2 slashes, this means Gen is not going to use that code that comes after the slash. Is just going to be ignored. But if we don't want to delete it, we just want to keep it there but not use it, we can comment it like that. There is another way of commenting, which is to use a slash and then an asterisk, and then we can use asterisk and a slash to close it. That's the other way. In this way we can comment multiple lines, right? We could comment all these lines here, which we cannot do with the slashes. We can comment only one line. So what's going on here? We are basically summing a sine wave which has a certain frequency, and each time we increase the frequency, basically, because we multiply it by I, which gets bigger and bigger at every iteration. And so we keep summing like sine waves to that for 5 times, basically. And each time they get bigger. So we get, we should get some interesting wave. Now, this number, -1 and 1, which the maximum value of y pos could be between -5 and 5. So we actually need to, in order to normalize it, let's just divide y pos by iterations. So in order to divide it, we could say y pos is equal to y pos divided iterations. Or we can also say y pos is divide equal to iterations. which means it's going to be divided by iterations, and the result is going to be assigned to ypos again. And that's what we get. In order to make this a bit more interesting, we have already a parameter here called time. We could sum time to that, which will give us animation of these sine waves. So if we go inside our patcher and instead of ypos here we write time, and then we can modify this number box and see how the y position of the cubes gets modified. We can also just create a jit time object to give us a number that continuously increases as long as the jit world is active. Could have more iterations, and this will give us very different results. At a certain point, the waves just kind of cancel each other or sum each other to the extreme. So let's see. We can modify that as well. For example, we could multiply y for something smaller, and this you have to imagine this is like the frequency of our sine waves, right? So how long is the wavelength, basically? The higher the frequency, the smaller will be the wavelength. At the moment we are only working with the x coordinates, so the y position for the whole line will be the same because it's only using the x coordinates, but we could, for example, multiply that by snorm.y, and that will give us a bit more interesting results, because now it uses both the x and the y coordinates to calculate these the y position. Nice. If we want to have more cubes, we can do that by simply modifying these numbers here. For example, we could have 50 by 50 cubes, so modifying the dimension of the matrix. In this case, we need to divide that by something smaller. So I multiplied the dimension of the matrix by 5, so I should divide the scale by 5, so that should be it. And now we have a lot of small cubes. We could even have spheres instead of cubes, but I think I like cubes. Cool. We could change the number of iterations using a param, so we can create here another parameter, call it iterations, give it a default value of 5. We don't need then to declare it here. Go in our patch, say prepend iterations, not use jit time, but just an integer number. Must be an integer, because we only can do this an integer amount of times. And we can see what else we got out of there. Interesting. We could play around a bit with the frequency here. By the way, we can also go on a new line without the code being broken. The important thing is that at the end of the line, this is something I forgot, at the end of the line we always need to put a semicolon. This is what gives to Gen the information that the line is over and we're starting a new line. It could actually all be on the same line. Gen will not care at all, this will still work. So this is mostly for us to put it in several lines, but the important thing is that at the end of the line must be the semicolon. So what we can do is, for example, to maybe sum time to that inside here and see what we get. Okay, we could get a lot of crazy animations. We could make the frequency here bigger and then let go completely crazy. We can maybe multiply time for something smaller. Yeah, this is just to show you how we can use for loops inside CodeBox. So this is it for this video. If you want to get deeper into the CodeBox stuff, I have a series of videos about CodeBox and jit.gen. This video is mostly just a refresher and a starting point if you are starting now to dive into it. Hope it was clear enough. If you have any questions, just ask me here in the YouTube comments, or join my Patreon and get in touch with me through Discord and also get access to hundreds of patches, including this one. For the moment, thank you for following. I will see you in the next video. Have fun. Ciao.